water. And this is exactly what you see here. So most of the glacier is really now behind this ridge, what you see. And what you also see is that this here is a debris-covered tongue. So this glacier is really a debris-covered glacier. And several of you already asked me why it is debris-covered glacier and how this glacier formed. So first of all, this glacier is a temperate glacier. So the temperature of the glacier in the ice is close to zero. It's of course not above zero because otherwise it would be gone, but it's very close to zero. And you've seen the vegetation here. It's a clear indication that you have a lot of precipitation, and you have even more precipitation up at Mount Gonga, which is probably the major source of the glacier. And you can see the picture here. So it's a massive mountain. You have a huge precipitation, so you have a huge accumulation, have a very large mass turnover, which means there's a lot of ice which can form and which can then flow down the valley. And because you have a lot of ice which can flow down, it can flow down very low in elevation, although it's very hot here. You can see, probably you even don't need a shirt, you can stand here in a t-shirt and it would still be okay. So it's a temperature, I would say something almost 20 degrees, and there are still glaciers. And this is because you have a lot of accumulation in the accumulation region. When you go to the Tibetan Plateau, and you see many other glaciers there, they look very, very different. They're way smaller. They are typically, depending where you are, they're sometimes even cold glaciers, which means that the temperature, the surrounding temperature is very cold, and they are frozen to their bed. This glacier is not frozen to the bed, and you can see it from many, many indications. And first of all, when you look at the tongue here, you see a waterfall which is coming from below the ice. This would not happen if the ice would have been frozen to the glacier bed. So this is clear that's a temperate glacier. Even when it's a cold glacier, there would be drainage on the top of the glacier. You would see some flow on the ice. You don't see any flow on the ice. All the water drains into the ice and flows below. And so I was asked regarding the glacier flow and flow rate. I don't know exactly how fast it flows, but I know from measurements of similar glaciers here in the region that in the upper part you have annual flow rates of 200 to 300 meters per year, while I would assume in the lower part at the icefall it should be something like 50 meters when I compare it. So for example, the icefall in Mount Everest has 50 meters flow rate per year, while here in the I should not turn around. In the lower part, otherwise you can't hear me. It's not working anymore.
No. Throw it away.
Okay.
汉德帮拿一下。
So I will speak a little bit louder and you can hear me probably as
Thank
well
you.
as with
Thank
this.
you.
And so the flow rate here, so this part here, it's not entirely stagnant. You can see crevasses. If it would be completely stagnant, there would be no crevasses. But it's very, very slow, and I would say it's something below 10 meters per year, and the lower part is even stable. And it was quite interesting to see, and that's very typical for these debris-covered glaciers, that it was very close to the terminal parts of the extent of the little ice edge. You see the trim lines here, up here. So this is the height of the tongue of the little ice age, and it melted down, so it down-wasted quite a lot, probably 100 meter or 60 meter. But the extent of the tongue is still close to the terminus where it used to be. So the retreat of the glacier is not as strong as of clean ice glacier, but the volume loss is as strong. And this is again what I highlighted yesterday, that if you only look at the length change, that's not the real signal. So it's really the volume change and the mass change which is the key.